It's not unprecedented to find a better algorithm for solving a problem which can be 100 times more efficient than the previous state of the art. 100 times. That is stupendous. Like if you're competing with other people, if you're in a business of solving some equations and you have 100x advantage, everybody you're competing with is completely eviscerated. You can offer the service so much cheaper, you wipe out all your competitors. It's that decisive. And that's how big algorithmic leaps can be. It's on a knife edge. What we do really in the next 5 years will determine that. It could be a much, much better world than the one we live in at the moment. And it could be a disaster which ends us pretty quickly.
Human nature gets in the way of decentralization, which is there to fix the biggest problems that human nature need to be fixed.
Baseline.
The baseline is designed to create an emotional response.
I've seen things you won't believe.
More human than human. Make you question everything.
Today, I'm joined by John Fletcher. He studied physics at Oxford, theoretical physics at Imperial, and he went on to complete his PhD in mathematics at Cambridge University, where we are today.
That's correct.
Beautiful place. He's the founder and chief scientist at the Innovation Game, where the team is working on some of the hardest problems in engineering, in science. This conversation's landing at a perfect moment. We're all kind of back from summer. A lot's happened. In August alone, we've seen OpenAI release GPT-5. We've seen Stanford demonstrate an autonomous AI and agentic technology that's discovering new treatments. But there's a real one I want to focus on today, which I think plays to the unique value of the innovation game, which is MIT is saying that 95% of AI projects in enterprise are failing. But we're going to explore with John whether the innovation game or this decentralized approach is really more optimum for the application of AI and Gen AI across business, and whether those traditional business rules of siloed, wholly owned projects that are seen as competitive advantage, whether the rules just need to change.
The innovation game, in a sense, is sort of more than one thing. It's a protocol for incentivizing the development of sort of more performant algorithms for science and technology and AI. But also more broadly, it is a structure which is not a traditional business structure. It's we've essentially created a situation where we crowdsource what is the product, which is the innovation, which we capture the IP sort of related to that innovation and make it available for license. But in the traditional world, if you were to do this, the people kind of inventing the better techniques would typically work for you. They would be employed in your company and sort of obligated to essentially if anything they invent, they would transfer the intellectual property rights to the company and so on. But in our case, what we invent in the innovation game internally is really just the meta invention. So it's basically a protocol or a network which provides an incentive for people to develop more performant algorithms. So that's sort of our sort of internally developed invention, and then that incentive crowdsources innovation around these so-called challenges, knapsack problem, vehicle routing problem, optimization problems, and all of that value is provided by anyone who cares to participate. Essentially, it's an open offer for a prize or a reward that you can get for finding a better algorithm in these areas. And we need not even know the person's name or where they are in the world. They can send in these algorithms, and if they perform better, they get rewarded. So all of that value, the essential, the kind of what will end up being the end product, is created by people who are not part of the innovation game team. They're simply it's crowdsourced from anywhere in the world.
I mean, I'm old enough to remember SETI.
Yep.
So in the early 2000s, I mean, I was in university late 90s, so like went into this idea that there's a whole load of data to be processed.
Yes.
It's too much data to be processed by a centralized computing facility. So we're going to decentralize this application for people to download chunks of images of the universe or whatever and analyze it.
Yes.
Obviously, since Bitcoin and that idea of incentivization through mining a token, it feels like it's a bit of both of those those hypotheses on distributed and decentralized workload, but with some form of reward.
That's right.
For the work.
So correct me if I'm wrong, but I think SETI really was a kind of a trailblazer, and you're right. Anybody could come in and join and participate with their compute, which did sort of scale it out. There's a lot of compute out there, right? And there are a lot of people who are sort of enthusiasts and maybe want to help with some kind of scientific project which they feel is meaningful. But I think with SETI that you didn't get you didn't get a kind of monetary reward. You didn't get a token. So this is great, and quite possibly it is a sort of sufficient amount of compute for them. But the thing that really takes it to the next level, and that happened with Bitcoin, is when you do get a reward, people won't just maybe use their spare compute. They will literally go out and buy huge numbers of computers and sites with negotiate cheap electricity deals in order to get that reward. So this is the real engine of capitalism. Once this gets going and you have a sort of credible revenue stream, you can even do things like borrow money to invest in more machines and then pay back the loan with the money that you're earning. And that's how giant enterprises grow. And that's the reason why Bitcoin is probably hundreds of times larger than SETI ever was or ever could be, because it spins up this engine of capitalism because you have this revenue stream. And those people don't necessarily believe in Bitcoin or believe in science. They don't have to. For them, it's just a business. And so that kind of Bitcoin sort of took it to the next level. But what you get with that is that's the positive side. But the negative side is that in SETI, people probably wouldn't kind of do nonsense calculations to try and trick the machine. Because what's the point? Like, you're doing it voluntarily anyway. You're not getting a reward for it. So why would you kind of try and be higher up on the leaderboard and send nonsense? There's no real incentive to do that. As soon as you introduce money, people will try as hard as they can to do anything, the wrong thing, send in nonsense in order to get the reward, but not have to do the commensurate work. So as soon as you introduce financial rewards, it becomes an adversarial environment, which is much, much harder to secure. And that's the reason why something like SETI hasn't really been fully kind of generalized to this sort of Bitcoin situation where you get the reward, because suddenly it becomes adversarial. And so it has to be so much more secure against sort of hacking and people basically just pretending to do the work and the processing, whereas they really haven't. They just try to sort of trick the machine into thinking that they've done it.
I think that this plays to a concern I have about decentralization. So
Yep.
firstly, if we analyze what's happening with AI, we're going back to highly centralized enterprises, looking at using AI to be a competitive differentiation, whether it's a margin play in terms of the cost of human resource versus automation versus can AI find solutions, can it find competitive edge. So we know that there is a centralized arms race happening at the moment, which in itself brings all sorts of concerns on security and all sorts of different issues. But back in 2016, off the back of the Bitcoin thesis, the view was, and the view that I certainly held was, the big problems that affect us all, like climate change, like the expansion of humanity into space, big genetic related issues associated to the human form that affect every human. Those big issues are going to have to be fixed through mega collaboration, which the Bitcoin platform, Satoshi's original thesis for a peer-to-peer network, for me, felt like the perfect foundational infrastructure to fix these big problems that required collaboration. Which was certainly part of my reason for forming the blockchain company that I founded. Probably part of the reason why you believe innovation came. The only issue is that which I want to try and get under, is that human nature reverts to that point that you've made, that antagonism, that gaming the system, and therefore collaboration like massively slows down when the more participants you have in the networks.
It can do.
Just see the problem. So it's almost like there's this idealistic panacea of decentralized control and authority for technologies like AI and data security or whatever, and indeed innovation. But then there's the human nature element of I want to win, I want to beat them, I want to compete.
Yeah, even if it means screwing with the system, which is everybody agrees is doing a good thing, they will do it. It will be done.
See the problem?
Absolutely.
And that's where I have hit this philosophical wall I can't get past. Human nature gets in the way of decentralization, which is there to fix the biggest problems that human nature need to be fixed. Yeah, no,
I think you're absolutely right. So I think to take a step back and think about what Bitcoin achieved, as I said, it was the first time that they were kind of offering this reward, but it's like you didn't have to sign up, you didn't have to give your name. And and obviously signing up and giving your name and being approved, this always becomes like a gatekeeping thing. And this is one of the things which sort of stops the sort of spread. One of the reasons why Bitcoin has been so wildly successful is there is no gatekeeping. But what you've got to remember as well is that Bitcoin is unbelievably simple. It's essentially the simplest possible realization of that idea, that sort of open blockchain idea, a public blockchain. And therefore it's the easiest situation to keep secure. So that people will try and screw with Bitcoin, people will try and, pretend they've done the proof of work when they really haven't. But because they've managed to get it so that there's essentially very little scope to do that. So then I think naturally people thought, okay, this is the proof of concept. We can just generalize this. It has been found to be very difficult to generalize. If you want to add extra complexity to they're not just, solving hash functions, they're doing something meaningful. You get this explosion of the attack surface, and so there's more ways that people can mess with it. And you're absolutely right. If they can mess with it, they will. It's just inevitable. At least one person will, and that will be enough if they kind of rent enough computers and so on and so forth. So I think, to me, what you're describing is possible, and I think that we have achieved a sort of a subset of that in a very well-defined kind of specific area of science with the innovation game. And I think more elaborate things are possible, but it was just underestimated how hard the problem is. It's very, very hard. And we could go into sort of the reasons why. But you're right, you always have to assume that at least a small number of people will be maximally malicious. They're going to try and screw with it. And if that is possible, your protocol is basically dead in the water. You cannot assume good intentions when you're offering a monetary reward. For something like SETI, you probably can. It's just not worth the time of a criminal to determinedly attack it. But if there's any money involved, they will. There's no question about it.
Well,
but you can't get the scaling without the money.
This is the paradox. This is the paradox. For me, the solution back in 2016-18 was technology called Hyperledger, which was private networks of known participants who could then participate in a cryptographic community that could access information. In our case, it was about private data and data being passed between different companies, etc. The issue was you couldn't drive adoption.
Yes.
Because there was no financial incentive or tokenized incentive to adopt, other than like power players just saying, we're the big central company, you will work with us.
Indeed.
But then essentially you still have a centralized...
Yeah, that's right. And it's not really like a grassroots, bottom-up movement. If you want something to be a movement, it has to start from the grassroots. Yeah, typically, it being orchestrated by a big company doesn't get the kind of passion which Bitcoin ended up getting.
So you accept that centralized authority doesn't work and go true decentralized, which is public networks, anybody can participate. But then you introduce an incentive model, ideally that has some form of absolute value and not some, shit coin.
Yeah.
And then you have to work out how you traverse human nature.
That's right.
That it doesn't become so toxic and unusable that it defeats the object of its original
That's right. So I think that, even though I'm quite a positive person about humanity, you've got to, when you're thinking about the security of the protocol, you assume the complete worst. You assume that everybody's like, there is a significant number of people out there who will do almost anything to kind of to get reward without doing the commensurate work, which in itself will ultimately destroy the protocol. And so for me, this is one of the reasons why it took so long. I think I mentioned that I had the idea 12 years ago, but the thing is, it wouldn't have been secure. It would have I could see ways, like if I was a real bad guy, I could screw with it, and then I could just, if I persisted, the thing would be destroyed ultimately. So I do feel, again, a lot of people maybe in crypto are just like, they have this great idea, it sounds exciting, and they just, go ahead with it, sell the token and let's figure out the problems on the way. Because it's so difficult, that almost never works. Either the protocol is destroyed, or they have to change it in a way which makes it trivial. It stops doing essentially the useful thing that it was originally dreamed to be able to do. And so this compromise, but then they get this sort of cult-like thing, we're going to do it in the future and all that, because the future never comes, right? So for me, I was like, unless I'm absolutely sure this thing's going to work, I'm not going to deploy it in the first place. I got to a point where I was sure, what I think as sure as something it reasonably could be, and now we're rolling it out. I would say it took years and years of asking people. I had this list of about 15 problems. I would tick one off maybe once every 3 months, once every 6 months, and in the end, I kind of got to the end. And again, it's a simplified situation. We're just looking at algorithms, and specifically algorithms which solve problems which are computationally hard to solve but easy to verify. But that is a very, very rich category of problems. So we're not claiming to be able to do all science or all problems or anything like that. And the reason why it is those problems is because that's the only problems for which it can be secure.
Tell me, what was the point where you thought, I'm going to go for it? Because you have an amazing academic history. You said you laboured this for several years. Mm-hmm. What was the trigger point where you thought, we can build something that is secure, that isn't trivialised in its execution?
And it's a great question. So I think there were two things which came together. One was the realisation of this equation.
The trivialisation can be summed up with blockchains, a technology looking for a problem to solve.
Yes, that's right. Precisely.
That's when you talked about that's what happens when you trivialise it to the extent where you're trying to trivialise it and make people understand it like it's a database or something. It's none of those things.
Yeah, that's right.
But to make people understand it for adoption, you trivialise it. Yep. How do you not trivialise it but not create the issue?
So I think you summed it up very well there, saying that this kind of slogan, which I think does have a lot of truth to it, a solution looking for a problem, is because like that solution is that's what we can build and for it to be secure. But if we try and build something more general than that, suddenly it becomes insecure. So we're not going to build that. So we just have this. But the problem is that doesn't solve any problem. As far as we know, we're looking for a problem that it will solve. So in my case, you started with the problem, right, rather than the solution, and it tried to build a system that would solve that problem. And initially, the system was just manifestly insecure, and that's what took so long to figure out a method to make it so that it couldn't be gamed and ultimately destroyed by bad actors. And for me, the point at which I realised that it was sufficiently safe against gaming, it was this equation. Strangely enough, that this stops people from the miners of the network, which we call benchmarkers. It stops them from the situation from rising. So if somebody privately finds a very, very big optimization to one of these algorithms, so sometimes historically it's not unprecedented to find a better algorithm for solving a problem which can be 100 times more efficient than the previous state of the art. 100 times. That is stupendous. Like if you're competing with other people, if you're in a business of solving some equations and you have 100x advantage, everybody you're competing with is completely eviscerated. That nobody can compete. They can't even, the electricity costs alone, you can offer the service so much cheaper, you wipe out all your competitors. It's that decisive. And that's how big algorithmic leaps can be. And so I had to assume that in one or maybe more of these challenges, sooner or later, someone's going to find a leap that big. And under the sort of plain vanilla kind of blockchain model, that would immediately centralize to that person, and the whole network would become insecure. They could do anything, they could write anything into the blocks, they could, and that would be. So it's almost like the protocol would be destroyed by success, because you're trying to incentivize people to find a better algorithm. But if they find one that's too good, everybody is wiped out. There's immediate 100% centralization, and not only that, but the thing becomes literally insecure. So that was the worst case scenario, in a sense, that you had to, from a security point of view, that you had to protect against. This equation, we can go into it, is the thing which protects against that. And the second trigger was I met my good friend and colleague, CTO Ying, who you met before. And so I do program computers. I programmed in C++, but I'm not really a computer programmer, not like he is. He's one of those people who thinks in code and writes code as fast as I talk, or maybe even quicker. So I knew you've got to know your limitations. I wasn't up to that level with computers and code. But once I met him, I knew that as a team, we could do this. So I explained to him my idea, and ultimately, we sort of partnered up, and other people have joined us since. So those were the two kind of main triggers. I mean, yeah, we're really kind of getting into the essence of it here, because it's, what can you do and it be secure? It always has to be secure. This is the thing. Like, I'm not saying blockchain companies are fantastic, but if something's not secure, it gets found out so quickly, it'll just collapse. So again, it's sort of, if you're going to be a little bit, kind of, as many people I think in blockchain are, a little bit sort of exaggeratory about your claims, you don't do it about the security, because that, fib or exaggeration will be found out very quickly. So the second element to it is, so you don't just have to have security, your economics have to make sense. And to me, a lot of things in blockchain which are secure at the moment, the reason it's gone the other way, they've trivialized it, the economics don't make sense. It's sort of, they're doing something, but there's no money flowing in on the back end. It's like all of their funding and all of their apparent sort of growth and success is from token inflation, which is largely due to getting a lot of sort of hype and enthusiasm around the potential of the protocol, which will never be realized because it simply doesn't make sense under the hood. So yeah, those were the kind of dual areas to me, if we're thinking about it.
Well, there was that whole awful era of ICOs, where it was all inflationary.
Indeed, absolutely.
All kind of proposed value for tokens, which really just went to nothing.
Well, that's
so
right.
A lot of people were stung, I think, there.
That's right. And sort of a lot of people use these kind of, naturally, it's human nature to use these kind of heuristics. Like, is this protocol successful? Like, is it getting traction? But, and people would always kind of draw that, this, Google didn't make profit for, many years or something like that. But, they had millions of users of their products and stuff. So, number one, they had very large revenue for a lot of that, even though they didn't make profit. So these protocols typically don't have revenue. But also, if I go out into the street and start handing out free iPhones, right? A crowd is going to form around me pretty quickly, right? But that doesn't mean this guy's got a great business idea. So why doesn't that work normally? It's because you just run out of money. But the problem is with blockchain is it allows people to print their own money. So they get an apparent hubbub and large number of people coming and using their protocol. They're being paid to use it. But the thing is, that can go on for a very long time because they're printing their own money to pay people to use it. But of course, ultimately, that can't work unless they're getting value in the background. You can't just be giving stuff out. You have to be getting something in. And these people who are using the protocol are not paying customers. This is the problem. They're people who are receiving a bribe in order to interact, ultimately. So we're going into a little bit of the generalization here, but it's like you've got to be so careful about what's really going on. Is this protocol really getting traction? Are they really getting lots of users? Or are those people simply coming because they're being paid? And when those unsustainable rewards run out, they just leave and go to the next.
So if we just strip it back, we talk about algorithms, and this may be slightly simplistic for your level of thinking, but I think it's important to determine that where are algorithms getting used in business right now, and what algorithms do we need? Because I think that just the idea of mathematics underpinning shipping, medical, I get scheduling, I get resource management, I can see algorithms around that, traffic you can kind of understand, keep the lights on for a certain amount of seconds. Yes. Can you just explain why algorithms are important?
Yeah, absolutely. I mean, you mentioned some great examples there.
That question's so silly.
No, it's the thing is, I think this is such an important question because people don't really perceive that so much. And also, to the extent they do perceive it, they don't think, oh, yeah, all the money's in the algorithms, right? It's like the early days of computers. People all thought the money was in the hardware, which really sort of in the software. That's where Microsoft, realized that very, very early on. But the thing is about algorithms, so we just give a few examples. So the shipping example that you gave is fantastic. So they put the crates on the ship. There are certain ways of packing them more efficiently. And recently, in fact, apparently Google developed a more efficient way of packing these ship containers. One of these giant ships that have sort of thousands of containers coming from China. And they say, and there's no reason not to believe them, that their packing algorithm is superior to an extent that it will increase the profit of these companies by 40% because of that. And again, it's sort of, if you're a shipping company, you can't really not have that. And so what they do is they say, that Google says, send us your inventory, we'll do run the algorithm, and we send you back the answer. They're not sharing the algorithm with them, and they're also getting the data about their inventory, which is probably very valuable. These guys would rather not give it up, but you can't not send it to Google because otherwise you're 40% less profitable, and ultimately you'll probably be run out of business by one of your competitors. So that's a very powerful thing. We have things like vehicle routing. Vehicle routing is a funny one because obviously it was named after the first application of the algorithm, which is to route literal vehicles around for deliveries more efficiently. But in fact, it's not limited to vehicles. More generally, it's useful, say, there was a paper, I think, out of Stanford quite recently about the vehicle routing algorithm used in robotics for sort of automated pharmaceuticals. So it means that they have to do less pipetting or something, the way that the robot moves around. It's faster, it's cheaper, again. So things that are moving around in the physical world, again, robots in Amazon warehouse, for example, there's quite a lot of that. And in robotics in particular, that is about moving around in the physical world. And these things can make a big difference. Sort of going into a slightly different category, there's something called non-convex optimization, which amazingly is you think of a surface. It could be in 3 dimensions, 2 dimensions. In this case, it's probably in thousands of dimensions. And you're moving a point around the surface and you're trying to find the lowest point on the surface. That's as simple as it is. You can define it very simply. Solving this problem in an efficient way is very, very difficult. And doing it is worth tens of billions of dollars per year because it's the main way that neural networks are trained. So when neural networks are trained, you essentially have a huge multi-dimensional function, which is sort of continuous, and you try and sort of basically find the kind of lowest value of something called a loss function, which essentially means that it's sort of kind of reproducing, it sort of internalize the data in the most efficient way. So this is what they're trying to sort of minimize this loss function in these sort of huge training runs, which are already costing billions of dollars. And there are, historically, there are very significant leaps in how to do non-convex optimization. The problem actually was studied by Bernoulli in the 1600s. So this is how old these problems are, in a sense. Like, they're very pure, beautiful, elegantly defined mathematical problems. He never knew that it was going to be used for neural networks one day or the various other applications. But this is another very interesting thing. Like, the set of these problems is actually very old and very stable. What is much more dynamic is finding better ways to solve the problems and also new applications for the problems, such as neural networks. And in fact, the highest cited paper in modern AI, I think it came out in 2015. It's called the Adam Optimizer. Is an optimizer for non-convex optimization, and it has like 220,000 citations, which is I don't think I've ever even seen a scientific paper with that many citations. It's so impactful because it's the most important thing in AI. It's the core of the technology. But one of the reasons why you don't hear so much about it, you hear a lot about data, you hear a lot about hardware, and the reason is because historically, and even really to this day, the big companies differentiate on data. They have sometimes different data sets. Google's famously got access to proprietary data sets nobody else has. Some people kind of buy data sets, from the New York Times maybe. And, people are scraping data. And also, people are buying a lot of hardware, like who has the contact at NVIDIA to get the latest 8100s. But they all essentially have the same algorithms. So they're not differentiating on that. Not yet, anyway. But the concern is, and it's a very, very plausible concern, is that soon they will be. And algorithms are such a powerful thing that a differentiator with respect to an algorithm could essentially lead to a monopoly. Because you sort of just eviscerate your competition. You find a better algorithm, they don't have access to it. You don't even have to buy new hardware. You deploy the same algorithm to your existing hardware fleet, and suddenly it could be like you have 50 or 100 times more hardware, but you don't have to pay the extra electricity costs.
The contemporary differentiator for the relative performance of GPT technology, which is our ChatGPT, which is our conversational AI, our generative AI, essentially three-dimensional, four-dimensional vectoring.
Yes.
The differentiator has been seen as access to GPU technology.
That's right.
Provided by NVIDIA, to the extent where the US government is putting export controls.
That's right.
NVIDIA is worth 5-6 trillion now. I don't even know. It could be 8 trillion.
That's right.
And there are lots of theorists who suggest we're going to hit the wall of capability of vectoring. Whereas from this early conversation, I'm starting to feel as though, why are we not more focused on algorithmic optimization?
That's a great question.
As opposed to horsepower.
That's right.
Or naysaying about the limitations of the GPT architecture.
Absolutely. So this is one of the things which frightened the market to such an extent. I don't know if you remember when DeepSeek last year.
I did. Very, very, very much.
So
they created the mixture of experts, breaking down from 256 to 16 chunks to give you more effective experts within the pre-trained transformer. And I've seen, obviously, mixture of experts become, that's just like it's almost like not a cheat code, but it's kind of like, modularization of a wider intelligence to be a bit more focused on where to use the resource.
Yes.
And I know they're doing all sorts of stuff, and that China are finding out GPTs left, right, and center at the moment.
Yep.
And I also noticed that it's gone away from X amount billion parameters being the differentiator. Yep. We've moved to different things now. But to this conversation, where are these algorithmic enhancements going to come from?
Yep.
John, who's going to do that?
So it's a great question. So I mean, the area is hard to say. I mean, better optimizer would be huge. Better whatever comes after the transformer, which is sort of led to, which incidentally was really the thing which kicked off the modern AI revolution. It was the attention mechanism, which then led to the transformer, and that was estimated to be roughly, again, 100x efficiency from the previous state of the art, which was kind of calling back to the attention mechanism, which I can't quite remember. It might have been Bengio who came up with this. Sort of basically a method of not sort of weighting all of the kind of snippets and tokens sort of equally. Some of them had more significance than others, during the training process. And they sort of folded this into a new architecture that was built around this. Interestingly, I heard that the transformer architecture was in some way inspired by a new chip which Google was developing called Tensor Core TPUs. So that somebody sort of sat down and said, okay, could we design a sort of an architecture, a sort of better algorithm for learning, which would maximize the sort of advantage this new chip architecture would give us? And then that's where the transformer came from. They published this very famous paper in 2017. Google just, they came up with it. They openly published it. In fact, a lot of people who worked at Google at that time were there only because they said, you can continue to publish openly, like you do in academia. Come and work for us, you get paid more, and you continue to publish openly. So in a sense, they couldn't really silo it or tuck it away. They sort of agreed with the scientists this was going to be the deal. But with benefit of hindsight, it's sort of seen like we gave away, the keys to the kingdom in a sense, because that's what left.
It was an evolution from the Apache Hadoop framework, offline data and prescriptive data analytics, batch analytics. So I know there's not a direct correlation, but remember a lot of this technology from Facebook, the Apache Cassandra technology, a lot of it was private companies not building to solve problems, to enable their core businesses. So it was almost like side projects that have now emerged as these global scale language architectures that are truly becoming, whatever, quadrillion-dollar businesses.
Absolutely. This is what happens. I mean, this is why open science is such a great thing. When you get the scientist in, they communicate, they bounce the ideas with one another. If you get stuck, you ask somebody else, what should I try? And Google, I'm not sure about Facebook, maybe Facebook too, until very recently, Google really practiced that, right? They knew that was a more efficient way to innovate. And also, if you come up with something amazing, even if you do publish it openly, it's like if you're Google, you're probably going to get more benefit from it than the other people anyway, sort of thing. So why not have that accelerator of openness as well, allowing the scientists to talk to one another, not saying, oh, it's a secret, you're not allowed to speak to somebody, you're in Facebook or at Stanford University or whatever. So, I mean, again, this kind of melting pot of creativity comes up with this thing, but you've got to realize that was the thing which triggered it. It wasn't a new GPU, and it wasn't a new data set which somebody found. It was the transformer, which is an algorithmic method. But again, people focus on this less because it's not a differentiator. It's not because it isn't the most important thing. It's because everybody has it because they published it openly. And, and again, one of the reasons why they published it openly, again, they wanted to get the right scientists. And so this was the norms of science say they genuinely believe this. They want to be able to communicate in a free way with other people. They want to be able to publish their work so other people can build upon it. These are sort of scientific norms, which a lot of scientists genuinely have kind of internalized. And so allowing them to do that makes you the best scientist. But also, in my view, it's simply dangerous to do it the other way because the algorithmic methods are so powerful. If one company discovers one and then they decide, oh, we don't want our competitors to find this, it could lead to a monopoly. And if you have a monopoly in AI, of all things, that's the most dangerous type of monopoly because it's almost raw power. It's the closest thing to pure power that we've ever, which ever come into our awareness. Intelligence is power, essentially, not sort of physical strength anymore, and preeminence in science and technology. But then the intelligence allows you to then start accelerating ahead in science and technology. You can use the AI to invent better drugs. You can use it to invent faster ways to multiply matrices, which in fact AlphaEvolve has done quite recently. And all these things are wonderful, but they're not wonderful if somebody keeps them secret and uses them to control other people.
So, agree. But that's human nature.
Yes.
The innovation game specifically. So the output, who owns the output of the work that goes into participating in these algorithmic developments?
It's a great question. So when somebody finds a sort of an algorithmic breakthrough, the ownership is assigned to the TIG Foundation, which is a Swiss association, and we own the copyright to that, and we at least have the right to file a patent on it. So the Swiss Foundation owns it. But very importantly, that assignment is a conditional assignment. So the inventor will assign it to us only on the condition that we release it and we make it available in perpetuity under 2 licenses. So one is an open, free of charge license, which allows you to use all of TIG's IP free of charge. And the main condition of that is that you would, if you process some data using one of these algorithms covered by our IP, and you make a product out of the output, you would be obligated to make your input data open. So this is the kind of thing that scientists do as a matter of convention, because if you say, here's my output, here's my wonderful product, if you don't have the input, you can't reproduce it. Right, so it's not replicable. You can't check that the claims are true. So for scientists, that's not an impediment at all. They're supposed to publish the data that makes the results reproducible. For businesses, maybe not so much. Maybe they have a proprietary data set and they don't want to be obligated under the terms of the license to make that available. And so in their case, there's a paid license option which allows them to keep the data private. But they have to pay, and the revenue from that is routed back to fund more open innovation. So, but to get back to the original point of that is that the assignment is conditional, that their work is released under those 2 licenses. So we couldn't say, oh no, do an open AI and say actually no, we're not going to share this. We're not going to be open anymore. We've just decided not to, or it's better for our commercial or something. All those assignments would be invalid, because they're conditional. So it's not like if you work for OpenAI, they never said, oh, assign my work, but only if you remain non-profit, only if you remain open. They're just employees. They assign everything to the company automatically. And then OpenAI are the ones that choose whether they decide to revoke on their promise or continue. In our case, we cannot. And this is much like Linux, for example. So, or like, I don't know, if you contribute to the GNU compiler, for example, C++ compiler, which is the original free software compiler that they use for Linux. Again, you assign over your copyright, the sort of rights to the contribution. But again, it's a conditional assignment, so they can never revoke that. It goes to the foundation. They use that right, that power that the property right gives us to say this will remain open forever. And if you try and take it and integrate it into your source code and don't share, then we will exercise the property right. We will say our property rights mean no, you're not allowed to do that. So they're all used in the same way. It's the same as the copyleft principle. They're used defensively to stop other people closing off the data and the IP around the algorithms. So this is the bargain that we make. And it means that, again, we couldn't turn back on that even if we wanted to. It's literally impossible because it's a conditional assignment.
This open vision that you have and the application of decentralized work and intelligence and creating these open algorithms, how do you seriously think that's going to play out? Because, actually, I met in Westminster. We were in a room with a number of high-profile private companies, global private companies who represent, multi-billion-dollar scale AI businesses that are moving very quickly. Multi-trillion-dollar, it wouldn't surprise me in the very near future.
Yes.
By the time people are watching this.
Yes. Facebook's multi-trillion, I believe, for example.
So if those companies are now supported by the governments as well, because people are realizing this is a huge step forward in terms of the transaction of the public with their data and their trust in these intelligence systems that are being offered to them. How can open really play to that when it's being seen as such a progressively lucrative technology play?
Yeah, it's a great question.
A
lot of people have this sort of desire for a sort of open alternative to be competitive, but the thing is, it will only ever be a pipe dream. You've got to have a mechanism to make it happen. And the regular open source machinery, although it's been spectacularly successful in some domains, does not generalize to AI. Unfortunately, this is recognized by the open people, by the non-open people, just universally. We do know that open projects can be unassailable. I mean, Linux, for example, no private proprietary operating system will realistically catch up with Linux now. There's too much development, it moves too fast, it responds so quickly, all these people chipping in. The thing is about Linux is it does not require monetary remuneration for some very interesting reasons to reach that critical mass and momentum. One of the reasons is, incidentally, it's very modular, so people who are open source enthusiasts can work on a widget at the weekend and they still do their paid job during the week, right? So that they don't have to rely upon revenue from contributing to the Linux project in order to do it. AI is a lot less modular. It's sort of more kind of monolithic. And these algorithms are quite monolithic too. So you have to look at the economics of it. I think that the origin of the open source movement really came out of free software, which was really mostly just, we're not claiming to have a mechanism. We just think this is like a moral imperative. We have to try. And it worked, and it turned out that when it really kind of went involved into the open source movement, that it happened that the economics did work out. But that was almost post hoc, right? Initially, it was just a moral imperative, and then it figured out, in this case, that people have the enthusiasm for open source AI, there is the moral imperative, but the economics don't work with regular open source machinery. So that's why you have to add additional incentives. The big problem about incentives is not getting the revenue in the back end, interestingly, that we found out. It's distributing the revenue to the people who created the value in a way which is sort of perceived as fair, in a way in which they will accept, and it won't sort of poison the community spirit. Oh, I did something much better than this guy, but he got more revenue than me. Oh, screw this, I'm going to go do something else with my life. So this was the most important challenge to solve. But if you do solve this challenge, open can be better unassailable, not just morally and kind of ethically wholesome, but like Linux, you cannot compete with it. Microsoft cannot compete with it. Google haven't competed. They've just given up, right? There's no point in even trying. And that's because of everyone piles on and improves upon one another's work. It's done in this open way so people can discuss the ideas with anybody in the world, so you get a better, faster resolution of errors, more eyes on bugs, so on and so forth. So it can be better if the economics...
Is Linux the exception to the rule there, do you think? Because as you're explaining, people pile it on, fixing bugs. It sounds like chaos to me. My optimized brain would think most scenarios where you have that level of participation, you end up with a thin layer of grey down the middle, whereas Linux has been a phenomenal success and it's way ahead, and like you say, it's not going to be. But is it the exception? Could you?
Well, yeah. I mean, if it was literally just people piling on fixing bugs, it would be as you probably know, the way the open source is structured a little bit more organized way than that. You have maintainers, which now in Linux probably can be paid because they have donations to the Linux Foundation and so on. But that kind of came quite a lot later. The maintainers are sort of like the gatekeepers. They'll check code. They're more likely to accept a pull request from somebody who's got a good reputation built up and so on. People who just want to start out in Linux, they probably start with like more menial stuff, which is easier to check. So it's not the exception to there are other very successful open source projects. Probably things like Apache web server, kind of great examples. GNU, compiler, and so on. There are relatively few very successul open source projects. They have to have a certain structure. The software has to be highly modular. Not all types of thing or program that you might want to embody in code have a very modular structure. So it had that modularity. It has other properties like almost immediate utility. So often people contribute to Linux because they literally want to see that feature themselves. They want to have that. So they're like, okay, I'll build that feature for myself, and I'll also contribute it to the collective. And then the feature will be maintained by other people and stuff. And that's even better, right? So there are incentives flowing in both directions. They're just not monetary incentives. But unless it has these kind of various properties, it doesn't work without monetary incentives. So yeah, you don't have the immediate utility. For example, if you're working on fundamental science, no one's going to add to fundamental science because they want to use that thing. You don't have a fusion reactor in your back because there's I already want to see this feature in my fusion reactor. It just doesn't make any sense. So there are various properties about kind of long-term incentives and short-term incentives. Linux, GNU compiler, Apache, they have these properties. But again, they get a lot of focus because they've been such successful open source projects. And people say, why don't we do that with this area of software? Why don't we do that with AI stuff? They don't have the same properties. That's the reason why it doesn't work. And so, but it can work. You just need additional economic infrastructure on top of it. And this is, I believe, what a blockchain can build. It provides incentives, conditional incentives, if certain conditions are met, and that means that you can generalize what is essentially the open source model to areas where it didn't previously work because the economics didn't work out.
Let's get to that in a second. There's one area that it did come up in that conversation, and I don't know where it's emerged from, but I don't know whether it's a deliberate or malicious misrepresentation. But this idea of open weights and open source specifically related to large language models. And whether it was mistakenly or deliberately misrepresented as open source, some of the large language models I felt as though were being talked about in this non-threatening open source way, when actually they're not open source. They're not revealing the underlying data set that actually provided them, probably because of maybe there's privacy or copyright or legal issues around that. I don't know. But open weights is a very different, as far as I'm concerned, a very different, sounds the same, but a very different definition of whether these language models are actually open or not.
Absolutely. So, I mean, a great example would be I could, write some code. I could compile it into a binary, and then I release the binary under an open source license. Okay, so I say, it's open source. You can get it under an open source license, right? It's not freaking source code, man. It's not open source. You can release anything under an open source license. I can release my birthday card to my wife under an open source license, or a handprint of my niece's. And it's just a license, right? And releasing something under license doesn't mean it's open source. You have to see the source, obviously. And so you're right. They're releasing what are essentially binaries. Processed information, just numbers, which are nonsensical. You cannot interpret what they are under open source licenses and claiming it's open source. It's not. Interestingly, even OpenAI hasn't got the chutzpah to do that anymore. They're releasing their open models and they're calling them all open weights. Yeah, because that's such a travesty to say that
GPT-5 OSS, is it? What is that?
Yeah, it's open weights, and to their credit, they do call it open weights. So it's an open weight model. It's not as powerful as their proprietary models. They're ones that they keep, and only offer over API. But yeah, they're trying to sort of catch up. I guess they're trying to get a bit of the, goodwill back that Mark Zuckerberg managed to get by releasing Llama weights but unfortunately calling it open source, which it isn't. And interesting that OSI, the open source people, did step in and say this is the definition of open source in the context of AI. They've released a new definition which is specifically targeted at that. But you're absolutely right. Unless you can see the data and also the methods by which it was trained, indeed to make it reproducible. So you could, at least in principle, take that data, run it by the same methods, and you would get the same weights out. Then it's not open source, of course, because you haven't got the source material in order to produce the end product.
So why you believe this blockchain architecture system can build algorithms that these private companies can't on their own? Because what we've essentially traversed, specifically in AI, is the idea that we have phenomenal successes with Linux and open source and global collaboration, with a degree of pragmatic management around it. It almost sounds like your architecture of the tiers of sounds a little bit like the Linux architecture with contributors and your terms at the innovation game, but I feel as though it's in the shadow of this private US arms race that has got some big dogs in that race. You've got Microsoft, Google, with Anthropic. You've got obviously Meta bringing hundreds of billions of dollars to talent acquisition and technology development, and then there's obviously OpenAI, which has kind of emerged from Elon Musk and Sam Altman and his Y Combinator experience, and that has built a consumer trusted, comfortable face that sits in every meeting room, every boardroom, every bedroom in many ways, because it's traversing business to consumer. And then you've also got obviously Elon himself with XAI, which seemed to come up much later, but certainly represents a certain socio-political movement, and that's competing for technology, competing for talent. But you've got the largest private companies on the planet competing over the ability to create trusted consumer-facing AI applied through consumer uses, through to business uses, through to military uses, through to every use. Everybody is completely drinking the elixir of what is the premise of vectored generative AI in lots of different things. Indeed, the AI writing the algorithms itself.
Yes, right.
So there's a whole separate trajectory. Yes, we assume that humans will build these algorithms. Well, hang on. AI is another participator in the algorithm writing game itself.
Absolutely.
So you can see there's a number of chess pieces here that are exceptionally powerful. And then there's this idealistic vision of an incentivized community-based network to provide open solutions to 4 or 5 big problems that you've selected, and I'm sure there'll be more in innovation game. But how do you see that playing out in the most optimum way? I guess it's a big question, but it certainly questions the reasons and the reason that innovation game itself exists.
Absolutely. So the first thing I would say is that we certainly wouldn't characterize ourselves as a competitor to big AI companies. The only exception might be part of Google. So Google have, like famously, that it was from their research operation that they got the transformer architecture. They have very much pioneered sort of AI-driven algorithm development with Open Evolve. As far as we can tell, Meta and OpenAI and Anthropic and stuff, they're nowhere with that. They're really engineering companies. So they're taking these methods, which are kind of known. They're deploying huge amounts of capital on GPUs, doing probably fantastic engineering to optimize all of this and get it working well. And then they have a product which is an LLM and AI which they sell to the world. Consumers, they sell to end consumers. What we would be doing is we're creating algorithms. We don't sell them to end consumers. These would be things that big tech companies might want to integrate and bake into their process. So Google is a bit of a curveball because they have done some genuine scientific research. They famously came up with the transformer. One of the reasons why they do that and other companies don't do that is very fascinating. So Google have a big problem with being dismantled due to antitrust law, and that this has been ongoing for a while. It was the same reason why AT&T spun up Bell Labs. Bell Labs did real fundamental scientific research, like the same stuff that they did in the universities, but actually even better because they get all these great academics to leave the universities and work there because they could pay them more. So why did they do that? It wasn't for commercial reasons, because you cannot really, basic scientific research is not really privately investable, and it's because its output is so sporadic and unpredictable. The reason why they did that was to stop themselves being dismantled as a monopoly, which ultimately failed. So they ran Bell Labs, but they were like, the government was like, leave them alone. They're paying for all this stuff that normally we have to pay for, basic scientific research in universities. So they let it go. It did produce a hell of a lot of good things, but monopolies are so pernicious. Then in the end, they were like, we just have to break it up. It's so bad what they're doing, gouging the entire country on their telephone bills. Google, it is strongly suspected, have the same motivation. So this research that they do is not commercially motivated. It's really to turn the attention of the antitrust people and make it less likely that they'll be broken up as a monopoly. So what we need is real fundamental research done on a genuinely commercial basis, not as some kind of deflector to not have our monopoly broken up, so that we can capture the value from it. And as I said, it is not privately investable, but it's not to say it isn't investable. Governments invest in it all the time. So why can governments invest in research, real scientific research, basic research into algorithms and so on, which qualify? It's because they have such a diversity of interests that they can capture unexpected spillovers from this research. So a lot of the time you're looking into, I want to accelerate the movement of this plant cell or something. And then you find out that it has this kind of other, spillover effect in, like DNA or, vehicle routing or something like that, which is not part of my business, right? So somebody else gets the value from that. Because the government gets a value from almost everything, right? So someone else spins up a business from some expected side effect of some fundamental research, they still get to tax that business, usually, if it's within their domain. And actually, not even all governments can do this. You have to have very well-developed domestic tech industry, so America, UK, and so on. So companies can't do it, most governments can't do it, some can, but an open global protocol can do it. It can have this diversity of interests sufficient to capture unexpected spillovers because everything is crowdsourced. You don't have to have all the people, and that's the thing which limits the scale. So because things are crowdsourced, you can fund genuine research, and so what we are is we're not a competitor at the innovation game with any of the big tech companies, except, as I said, partially Google, but not because of that operation is not run on a commercial basis. So we would be the first commercial, privately funded fundamental research operation. And then what we really do is we sit above the Googles and the Facebooks of the world. They use the stuff, just as they've used the things that came out of academia historically, and they are our open common layer. We're not saying better deal for Google, but everything's done under a non-discriminatory license, so everybody gets the same terms. So we don't pick winners. We simply provide the technology. So it's almost like a privately levied tax, more like than a commercial company. And it's global. And what we are competing with is really government-funded research, not private research. So that's another way of saying that we essentially have no competitors, because the government doesn't even want to fund this stuff, right? They're not like an incumbent who's going to crush the new guy who comes along. They're like, blimey, if somebody found a commercial way of funding this stuff, hallelujah, we have to put less of our tax. They're not going to lower taxes, right? They'll just say we have to spend less on scientific research. We can spend more on whatever they want, weapons or something like that, whatever the government likes to spend money on. So it should be sort of perceived as kind of a layer of global infrastructure which is neutral, takes the role of kind of fundamental research, which private companies overwhelmingly, do not get involved in because it's too risky because they can't capture the spillovers. So that's the right way to look at the innovation game.
Where are the outputs? So have you achieved any groundbreaking algorithms, and where are they? And if they're open source, could I build a company wrapping one of those into some sort of commercial offering?
Yeah, so we have achieved an algorithm which is sort of beyond the state of the art in quadratic knapsack. At the moment, we still just have 5 challenges. We have some kind of rumor that we have another state of the art algorithm. I won't say for which challenge in the pipeline.
Oh, go on, John.
So that would be basically we've been sort of pushing this out publicly for just a year, and pretty soon we'll have world-beating algorithms for 40% of the challenges that we have. So that's pretty good going for the first year.
It's amazing going. So the 5 or 6 problems, you've essentially fixed 40% of them beyond state of the art.
Indeed, that's right. And one of the reasons you've got to remember, like the scientists who participate in this, for them it's a strict positive. So it's like they still publish openly as they normally would. It's simply that they'll then put the algorithm into the innovation game. They still got all the credit. They're the inventor of the algorithm, of course, but then they get remunerated for it, which they wouldn't before. And you can't really capture the value that you create as an academic. This is the thing. It's very, very difficult for some interesting reasons that we could go into. But the innovation game, we believe, solves that problem. So it's just the same for them, except for they get more monetary reward. So it's basically a no-brainer. And as I said, we have one of the big things about is like Web3, we're going to do a decentralized version of Facebook. We're going to do a decentralized version of Amazon AWS. It's like, good luck. You're competing against this titan of an incumbent. We have no competition. There is no one doing or even attempting to do what we did. And the reason is because it made no private commercial sense before. There was a market failure with respect to fundamental research. The innovation game's proof of work mechanism specifically fixed that market failure. So we can do a thing commercially now, which wasn't possible commercially before, and that's the reason where there is no incumbent.
Well, I think there's always been a chasm between academia and private business.
Yes.
And what would leap the chasm is the person.
Yes.
You know, the graduate schemes were the beach of the island that is, you know, corporate career.
Yep.
And you would emerge out of academia, publish some papers. I know people go on to do more and more PhD level, maybe to stay. But then they themselves would probably leap or be recruited into a business, and then their brain application of their ideas and career would then grow with the company that they'd been recruited into.
Yep.
But there was always a chasm.
Yep.
I feel as though what you're essentially doing is giving the people at the end of this period the opportunity to commercialize something that would have been open anyways in their journey across that chasm if they choose to do that or stay in academia.
Yep.
But well, I mean, what is the scale of commercialization for somebody who creates an algorithm beyond state of the art?
So it depends on the field, but at the extreme end, something like the optimizer, non-convex optimizer could be worth tens of billions a year for just one company.
What does the person who participated in innovation game get?
Oh, they get a reward in tokens, and they get it's quite interesting. So if you had something that valuable, it would be an interesting play because the very fact that you put it in would cause a huge uplift in the token price. So they would get their token rewards because they would dominate the benchmarking. Presumably, everybody would adopt it. Then because we had that thing, there would be revenue driven. By the license fee is payable in tokens, and that demand causes the token price to go up. So they would get a lot of tokens whose value would go up a lot because of the thing that they invented. It is, it would be sort of, a considerable amount of money. I mean, at the moment, the person who has the sort of, who put in the knapsack problem is probably earning about, roughly about sort of $5,000 a week, I think, for that. Which for somebody who was just going along in their academic job,
it's a huge amount.
It's quite an extra.
So is it the TIG token? Is that on Coinbase? Where is that? Which exchange is these tokens on?
So actually, interestingly, it is on Coinbase. So you can buy it on the Coinbase app. But the reason is currently we're not officially listed on the Coinbase exchange, but we are on Coinbase's blockchain, which is called Base. So you can buy the TIG token just straight from the Coinbase app. If you're anybody listening, actually, I think maybe that's restricted to America at the moment. But then they have another app for the Coinbase blockchain specifically. So if you're in America, you can just use the regular Coinbase exchange app. But if you're in the UK, you can use the Base app. I think that's the thing. So it's very easy to find. That's really the kind of the asset which sort of kind of backs all this and enables all of the monetary flows.
Well, just closing out, why do you think that whole academia versus commercial business, vocational business is a fascinating area. I'm in Essex University on Thursday talking to brain-computer interface again. I mean, I'm spending more time in universities, ironically, after spending 25 years in business. But one thing we have seen is a little bit of the trough of disillusionment with the application of AI projects in enterprise.
Yep.
I know now I know more about what you do. This is a slight parallel, but I would be interested in your view on it. A lot of enterprises have took this, what I would say is what they did with blockchain, which is let's kick the tires and see if this is a threat to our way of working.
Yeah.
The banks and pharmaceutical companies created these innovation teams. Let's do a blockchain pilot. Let's do an AI project.
Yes.
And let's see if it actually creates a cost optimization in our call center or in our quantitative algorithms or something. We'll do it.
Yes.
And from everything I've seen, it's been run under a traditional executive leadership team. They've brought in existing teams, they've brought in AI experts, whatever that is. And, MIT are saying, of the 300 major AI projects they've analysed, 95% of them have failed to deliver any meaningful return on investment. And it just sounds to me like it's this, let's kick the tires on modelling an existing process through some sort of cognitive or generative AI system, and we'll be biased to it failing because we're protecting our existing infrastructure decisions and domain of authority.
Yep.
So it's failed, we move on, which is what I saw a lot with decentralized technology in terms of data protection, data sharing, this sort of thing.
Yes.
But if AI is so hyped and valuable, why do you think all the projects are failing to deliver ROI?
I think it's a great question. So that, you'd have to, it might be a sort of case-by-case basis. You have to look kind of more specifically at what the project is.
Well, I had the idea of an AI project in itself.
Yeah.
If we're going to do a project on optimizing, fluvial flow through a random topology, let's do that. Let's not do an AI project on, just see what I'm saying.
That's right. So it has to be, I would say that one of the reasons, that it may well be is that you have to be very specific about the application. The degree to which it can help is very application specific at the moment. So it's not like a person or get a smart person in. They could probably do pretty much anything. So I just want to say I want them working on the thing that only they can do, right? I don't want to say if I could hire somebody at 30 grand a year to do the job that some guys paying to 100,000 a year to do that is wasted. But the guy at 100,000 a year can probably do everybody's job, more or less. But he's sort of wasted on most of the jobs. The AIs are not like that. They have very narrow things that they can do well, most of which they can't do well for some quite interesting reasons. And also you have this sort of funny effect whereby if you sort of test them, they seem really smart, but like the thing that they're good on 90% of the time is the thing that you don't need them to do. So if somebody rings up in a call center, often it's because they might have already asked the AI, what's the answer to this? The AI doesn't know because maybe it's something which is, which the data mainly gets wrong. It's like a sort of, they just churn out whatever the data is ingested, right? They don't make a value judgment as to whether the data, what they are given in the data is correct or not. They say like the majority sort of rules, and that is, we define that as the truth. So if you ask something to AI, it gives you some nonsense, and you ring up somebody and they give you an AI response, by definition that is not going to be the thing that you want, really. You rang up because you want to speak to a person who can actually reason about this edge case that wasn't covered by the AI. So I think, again, so there are incredible cases, like I think just one example of a sort of AI. They had this thing where they want to turn the parcel so the label was up so that the machine could scan it. And so they got like an AI hand to like try and turn the parcels the right way up. And they found that like the AI hand could do pretty well, like 49 out of 50 parcels, it would do fine. But they had to have a guy there to do the 1 in 50. It was like, the AI can't do it. But for them, that was great. They could reduce their workforce by a factor of 10. So that was an AI project that succeeded, right? So then he's got this completely other application, another robot doing cataract operations, right? So like, okay, again, the AI in 99% of cases could do the cataract operation fine. So you think, okay, we can just like, maybe we'll have the same thing as with the robot arm. We just have a surgeon kicking back there, waiting until the AI finds something that it can't do. The problem is because the surgeon isn't working all the time, he's de-skilled. You have to have the best cataract surgeons in the world are the ones who have done the most cataract operations. Actually, the guys who work on the mobile cataract trains in India, because they do so many, and it's just about repeat, repeat, repeat. So if, unlike the guys turning parcels, it's not an incredibly fine-tuned motor skill, which you degrade at quickly if you're not doing all the time. So it's like, what's the difference between the cataract eye and the thing? On the face of it, they seem the same. And actually, they're completely different. In one case, utter fuck up. You waste millions of pounds on cataract robots. In the other case, you reduce your cost by a factor of 10. So it's it's case by case.
Fascinating. The driving is, I mean, for people to be sitting passive in cars and actively driving and concentrating on the road and looking at weather conditions, they're going to de-skill driving just by sitting in vehicles.
That's why,
driverless cars is going to be, you've either got to make the leap.
It's all or nothing.
Not.
Exactly, precisely. Yeah. That's right. And so any applications that are all or nothing are terrible applications for AI. They started doing the cars first, right? Mm-hmm. And it's like 20 years on, they still can't do it. Mm-hmm. They picked a terrible application because, again, it's an all or nothing one. You can't have the guy just chilling out, having to take the wheel every 100 hours or so. It's a disaster. But not all applications are like that.
John, you are a fascinating, passionate person. What you're doing at the Innovation Game is hugely interesting. I'm so excited to watch what happens with it over the next 12 months, never mind 12 years, because I think that you're one of the very rare people I've met who traverse that vocational academia so well. And the whole decentralization blockchain thing, I've existed in that a long time. I get a sense whether people, you know what I mean?
Yeah, I know what you mean.
And I get the sense with you that, I've learned so much just in the last hour. Absolutely fascinating. AI is such a provocative topic at the moment. We've talked about the all or nothing application. We've talked about the idea that the level of commercial upside and competitive differentiation across a whole set of applications, whether it be financial, economic, or socio-political on a global level, is so important. But this all or nothing thing, I think, is so important because it is important that we don't de-skill our own people and ourselves, and there's a very fine balance there. But John, do you believe AI will take us to a utopia or dystopia?
I believe it could still be either. So it's on a knife edge. I think it's what we do really in the next 5 years will determine that. It could be a much, much better world than the one we live in at the moment, and it could be a disaster which ends us pretty quickly. And there are a few factors to that, I think. One is the sort of, and also there are different types of dystopia. You've got to be very careful. There are at least two big threats. One is like a guy gets sort of control of a very, very powerful AI and uses it to control other people. Or a kind of small cabal of people. They don't really release the technology because otherwise it would just, help people copy it, maybe catch up with them. So they keep kind of secret, super advanced technology to themselves, use it to control people, maybe leak out some kind of like very old version of it just to sell to people, in which they get almost 100% market share, right? Because it's still 3 times as good as the nearest competitor, but they keep the best stuff for themselves. So that's a dystopia. It's kind of like a police state. And then there's the other case where an AI sort of basically gets out of control, starts to, people freak out, want to shut it down, but it's smarter than them, so it takes some evasive action. So that could also cause a disaster. But both of those, to me, are equally unacceptable. Some people say, I'm not so worried about the kind of the police state thing. I'm worried about, or I'm not so worried about they're both unacceptable, right? It's a false dichotomy. So you've got to find a way to fix both of those. The Innovation Game, I believe, is a very long way to fixing the police state dystopia one. The one about the AI taking control is quite a separate problem. I also have some ideas around that, but I know we're running out of time now. But basically, there's these dual challenges that need to be tackled. But it is tackleable. It is possible. So-called, narrow path between, like Paul Atreides. But I think that people just have to freaking wake up and stop just trying to sell LLM models to make money, right? Like pretty soon, you're not going to want for money. You're not going to want for anything if this technology goes correctly. So I think just like trying to fill your boots while not thinking about the big picture, I think is something that people need to really kind of ease off on. I mean, you need to think about the big strategic problems, because this is not like any other technology in history. The problem is everybody says that about every technology, right? So it's like cry wolf. Nobody will believe you when you say. But it's very, very easy to see how, because previously technology is a tool. And if people are mostly good, they use the tool to try and help people, to a large extent. This thing is not a tool. It will be an agent. And as we saw with the kind of anthropic safety tests, it starts to have its own ideas if it's cornered or believes it is cornered. No technology in the world, obviously, has ever done that before. and that's because this technology is intelligent. So it follows different rules, and we just have to be very, very careful about extremely powerful things.
We are in a computer game.